In this video we're going to look at the reactions of the alkali metals lithium, sodium and potassium on water, and we'll start with lithium. In each case the metals are stored under paraffin oil, and the amount of metal that you use would be roughly a small lentil size. You will need to cut pieces of the alkali metals into suitable size. I tend to use a chisel or a fixed blade scalpel. Note there is an oxide layer on all three, which you may need to scrape off. With all three alkali metals, you will need to get rid of the layer of paraffin oil. This is best done in a dry conditions of using filter papers to blot off the excess paraffin. Otherwise the paraffin will get between the metal and the water. With the less reactive lithium metal, you can trap a small piece under a boiling tube that's been pre-filled with water. This requires a subtle flick of the wrist, and if you can't do that, the alternative is to get a forceps and hold the piece of lithium under the tube. You can't use this method with sodium or potassium. The tube fills up very quickly, and then you can test for the gas. The alkaline solution made can be tested for in one of two ways. We can either use litmus paper. Since we're testing for an alkali, we'd use red or neutral litmus paper, so it'll go from red to blue, pink to blue. We could use universal indicator paper, or in fact we could use phenolphthalein solution, which is also what we've done here, because I like the beautiful pink colour that's formed. Pure hydrogen collected this way doesn't pop, it simply burns. So one way of getting round that is going to make you look like an idiot. Take a tube filled with air. Remember, test tubes or boiling tubes are never empty. Take a tube filled with air, put it underneath the hydrogen tube, hydrogen being less dense than air will float. Mix the two together, split them so the tubes openings are facing downwards, and you can set fire to both one after the other, and you should get the characteristic flame color of lithium, in other words dark red. We're going to look at the reaction of sodium with water in three different ways, and we start each with the drying off of the paraffin oil. We're showing you here that if you slice open a piece of sodium, you'll see the typical shiny grey surface of pure sodium rather than the corroded outer layer. Chisels are very good for this. In the first experiment, the typical experiment, we put a small lentil-sized piece of sodium into the water. This is a very clean trough, and we'll see the sodium do a number of things. The first is it floats. Sodium has a low density. Secondly, the reaction with water is such that the sodium metal reshapes and becomes a ball of molten sodium. I think the melting point of sodium is somewhere near 98 degrees centigrade. There's also gas produced, which of course is hydrogen, and that propels the globule of sodium across the surface of the water. Now if you use a dirty trough, it occasionally means that the sodium will stick to the side of the trough and explode. If you put a piece of sodium onto filter paper, effectively it anchors the sodium in place, and the sodium metal overheats and explodes, putting small pieces of sodium potentially onto your bench, so you'll need to mop that down afterwards. But be aware that the cloud produced is of sodium hydroxide, and getting that into your lungs will make you cough and splutter yourselves for a few moments. Not recommended. The third way is to put some phenolphthalein solution into a clean water supply to start with, and that way you can see the tracks of the sodium hydroxide being produced behind the fizzing piece of sodium as it moves. With all alkali metal experiments, at the end of the session, put used filter papers and even the scalpels, used tweezers that have been used, into the trough of water. Don't put them in the bin where they could possibly get damp and ignite the contents of the bin. As with the other alkali metals, potassium is stored under paraffin oil. It tends, because of its increased reactivity, to have more oxide coating, so you may need to chisel away or cut away the oxide coating with a single fixed blade scalpel in advance. Use small bits. Ensure that the lid of your potassium container is shut. As you will see from the experiment, the bits of flying potassium could go anywhere. Make sure you mop down the workbench afterwards with a damp cloth to pick up any small pieces of potassium that may have escaped your trough.